He's worked across Australia and internationally in regions like Kazakhstan, West Africa, Chile and Mongolia. Rob's passion lies in mentoring teams, auditing operations and setting up new labs, helping optimise their processes and performance. Please welcome Rob to the stage, everybody.
Is there anyone actually currently looking at building a new laboratory facility on a mine site? Just out of interest? It's really interesting because having built a number of labs or commissioned a number of labs designed by other people or other groups, there's usually not enough research done before the mine lab is built, and it ends up being too small or too big, and it doesn't do what it was supposed to do. I've been to many labs that have unfortunately had to change and move forward. Okay, so the role of preparation labs on mine sites is largely to receive the sample, and the samples quite often come in as a solid from the mine section, or it might be a slurry, or it could be a solution. So the sample preparation guys basically have to receive that sample. They might have to filter the slurry and separate the solution and solid. Then they need to dry the solid, obviously, and then send it on through the processing of preparation to make sure it's ground and even, and then push it on through to the guys in the laboratory. This all takes a little bit of time. The idea is to have a representative sample. So a poorly designed prep lab can lead to delays in the end product. It can lead to incorrect results, potential for injured personnel, damaged equipment, unmotivated workers. So if you have a poorly resourced and maintained prep facility, it also means inferior outcomes because it can be delays and you can have samples destroyed or contaminated. The problem with that can be, do you know that that's happened if it's contaminated? And therefore the data that's used, is it going to impact the mine and its productivity? So looking at the various challenges, I'll start with safety. Resources such as dust extractors, for instance, are good to keep our staff from breathing in the dust. Various mine sites have different sorts of dust, including asbestos, of course. So, I would strongly recommend that vacuum waste management is used. I do see a lot of mine sites that have pressure guns. The first thing I normally do when I go to a mine site is remove all the pressure guns, because when you use a pressure gun, where does the dust go? It goes everywhere. So you take them away, you make sure you have extraction hoods, you make sure you have vacuum guns which suck things out of the bowls and all that sort of thing, and you make sure that nobody's got a pressure gun. There's a very small finite area where you might need a pressure gun, and that might be because you're using riffle splitters, okay? So you should be putting your riffle splitters inside an extraction hood, and if you have an air gun to clean that, you need to crank the pressure right back, so it's just a fine spray so that none of the dust comes out of the fume hood. Okay, going into quality. Quality starts at the front door, of course, and you want to make sure that the samples are submitted with some sort of documentation, so you actually know what you're supposed to have received and you know what's required. You also want to know what sort of urgency you've got on this batch. I can strongly recommend, from my years of use in labs, which have both been with and without LIMS, it's much easier if you have a LIMS because you can pre-register your samples. Often someone can send you an email with the information, which can fold straight into the system, or they can send you in samples which have a barcode, and you can just go boom, 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 and you know exactly what you've got. And nobody does a typo error when they're writing it down. And so when the sample comes out the other end, they actually know what they sent in, and they get a result for the sample they sent in, not a sample result for something they never sent in. So, and missing samples. So the other side of the process is doing check samples. In this process, replicates are very important. Quite often you'll find that millwork samples are all done in duplicate, for instance. It could be that if it's grade control, 1 in 20 samples might be split and put in a separate packet so that when you get the results back, 1 in 20 samples will have 2 results, and you can say, oh yeah, they look like they're the right data. If they're not the right data, then the lab can go back and do repeats through that section just to work out what went wrong. Every shift should end the shift with a complete cleanup. The reasoning there is you want to reduce your contamination. You also need, therefore, a lab that can be easily cleaned out, and the layout with all the equipment so that's not, you're just basically going to trip over things while you're trying to do these processes and clean it out. So that's a pretty big part. So what are our inefficiencies and costs? So process bottlenecks. We talk about the submission timetables. We've talked a little bit about LIMS, having that so that it speeds the process of getting the samples in. If you don't have that, you've got to have a good list. Make sure that you go through the samples, put them in the trays, put them in the drying oven. Guess what happens? The longest time it takes for the lab is drying the sample. And therefore it can be the size of the sample that's important. It can be the type of material. I mean, I've been doing sludgies that are 25 kilo samples, and I can tell you it takes about 3 days to dry a sludgy. So you've got to make sure, if you're going to do sludgies, is there a process you can do to speed that up? And there is. I won't talk about it now, but there are processes you can use. Okay, so the other part of it is our waste management. You want to make sure, for instance, you've got bins on wheels, and you also want to make sure that the wheelie bin can go actually straight to the end of the walkway, so it can go out to a big bin, so you don't have to worry about how am I going to get this out of the room. And you also want a big bin that can be picked up by a forklift or some manual mechanical means to be able to get that into where it needs to go to be wasted out. The equipment failures are a big one. I often go to mine sites, and the maintenance department on the mines normally go, we don't go to the lab. They look after their own stuff. And I talk to the lab people and they go, we can't change a bearing on a mill. And I go, well, how do you do that? Well, we actually have to take the mill out, put a new one in, send that one off to Perth, get it fixed, and then switch them out later on. And you know, these sorts of things become quite inefficient. So a mill goes down, that can mean waiting for hours, days, and that might reduce your productivity. So looking at the rework and retesting, if the process is well laid out and all the items are available and training for staff is effective, errors are less likely. This means less rework, potentially resampling from the mine might be required, because a lot of the times you go to a mill site and they process the sample, they mill it. If there's something wrong with that sample, they've actually milled the whole sample, so they've contaminated the whole sample. The only way to rework that is to go back out to the mine. Go out to the mine, they've already blasted, they've started to dig it. You don't have that result, it's gone. Okay, so your staffing. People are really important, and we all are aware of that. We all feel we're pretty important in our process. If you have the wrong staff or haven't got the appropriate training, then obviously you can't do the appropriate work. Training impacts your quality. Consistency in processing is also valuable to consistent results and the outcomes, such that all staff should be processing exactly in the same way as possible. The levels of appropriate sampling regime, are staff being trained to a certain level? Do they all have the same training? At least say there's a baseline. You might be above that, but at least you know the same baseline. Turnaround time requirements are important for staffing. Information from that submission team to the lab, they've got to go, oh yeah, gee, actually all that stuff we're doing, put that aside, we've got to get this out in 3 hours. I don't know how we can do that, but that's what's important. So, you know, the staff need to know that. They need to know how to do that. You need to be able to maintain the focus for the staff and try and make it interesting. It's probably one of the most dull processes in a lab is to crush the rocks and mill the samples into pulp packets, and then go and get some more samples and do the same thing again. If you're doing that all day, 7 days a week, 12 hours a day, if you can imagine, it's not very exciting. So on a lot of mine sites, the staff that do the prep today are doing the digest tomorrow, and the next day they might be doing the actual analytical work. So that's a rotation that you can actually set up on your mine site. We did that at Murchison Zinc, and everyone gets a chance to do something different. It might take a while to train some of the people to do that, but at least they know there's some sort of progress and it's interesting. So working with team focus, labs must work as a team. If someone drops the ball, it should be a smooth transition for another team member to move in and pick up where that previous person was, especially in the case of sickness or overwork or somebody gets injured. Hopefully not. So focusing on what we've just been talking about, there's the safety, the quality, the delivery, the equipment, the costings, and the staffing. Good design equals good performance. Think about that. It reduces your wasted time, helps prevent accidents, and keeps people interested. Good communication is extremely important. This is where I talked about the limbs. There is probably other ways of doing it, but if you want to keep time to a minimum and provide people with long-term information, which we talked about today with Artie, if someone wants something from last week or 6 months ago and you weren't there and someone comes and knocks at your door and says, I want the results for this, we need to go back over it. Good thing about things like some form of limbs, like a CCLAS or others, is that you can actually go in there and just type it in and bingo, there's the result from 6 months ago. It's got the information, who weighed it, who digested it, who ran it on the instrument, and it even has the weights and everything. So you can actually go in and just say, oh, okay, actually the calculation was done wrong. Well, that's what happened. I wonder what happened. So they can actually fix that and go back and recalculate it and get it right. So going through the process, you can prevent accidents, but the key here is that you can also improve your productivity, maintain that, and the customers will receive the results on time with the data they can trust. Trust is very important. You'll find that metallurgists and chemists often have a bit of a bingy because I don't trust what you're doing. Okay, so the success story, I've got an interesting one, and I don't mind telling you the company, Pilbara Minerals, when they were setting up. So I got out there on about the 3rd month after the processing plant was just finishing its commissioning phase. They had a contract group out there, and I was asked by the geology team to come out and review and do an audit, which was very interesting coming from the geology team. I thought, well, why are they asking? But anyway, they got me out there for a week. And so I started at the actual drilling sites where they're doing the sampling on the drills. Went to the plant where they were crushing all the material and going to all the different sampling points to see all the samples coming out. And then I went into the lab, see what sort of resources the lab was given. And I then went and read through the actual request from the company for what the lab had to do and what they preferred them to do. So as you probably know, Pilbara Minerals is a lithium mine. What's interesting about that is the mineral is extremely hard and abrasive, okay? So I went through the lab and I was looking at the sample prep and I was going, you're using a really abrasive mineral going through and you're milling using what we call LM2s, which was a 2000 cc bowl. I thought, well, that's a good size sample, but it's steel. I wonder what the problem could be. So I went on and looked through and had a look at some of the data and had a look at some of the samples coming through the system. So I went back to the geologist and I said, what particularly is your issue? And he said, well, the samples we've been running through our Perth lab, we've been doing splits of those and running through the local lab. And the data coming through the local lab is coming up with a whole bunch of stuff that we didn't see in the samples we sent to Perth. And the lithium grades are much lower on the site, mine site lab, and we don't know why. So I sort of looked at that. I went to look at where they did their assay work in Perth. I spoke to the Perth lab, and they were running the samples through a tungsten carbide bowl. On the mine site, we're running through a stainless steel bowl. And obviously that's where the mismatch was. So I went back into the lab. I saw on the shelf 2 tungsten carbide bowls still in their box, never been taken out. So we had a big meeting with the lab and the management team that had asked me to come out to the mine site and some of their specialist people in Perth, and I said, guys, you were told to use tungsten carbide bowls, you're not, can you explain? And they immediately realised the mistake, went back to using tungsten carbide bowls on the mine site, and then suddenly the benefit there, less contamination happened, the lithium results improved, which was a direct correlation to the fact that they were using the wrong bowls, and that had obviously added dollars in the geological resource and final product for shipment. So they were all very happy. So that's one of those things that it is often a mismatch. You just got to go through and actually understand what the lab is doing and why they're doing it. In that case, the people hadn't been trained to use the tungsten carbide bowls. So how to get it right for the lab design? Lab design will benefit from knowing upfront all the requirements that a lab must meet. The lab client should be part of the design if you can. If it's your own lab that you're designing and you're going to manage that lab, you should have employed someone who's going to run that lab. Preferably do that before the lab's built. I know that might sound too soon, but guess what? If he doesn't know, he won't get it right, and you won't get it right. After the designing, a further meeting with the client should be held, and it should be done on a regular basis, preferably at the commissioning phase, quite regular, and then after commissioning, you might do it once a month. But you should make regular meetings so that you can discuss what's happening, what's improving, what might not be working, so that both sides actually know what's going on. The costs, it's a really tricky one. In general, if you're asking for a faster turnaround as a client, you know, faster turnaround usually means higher cost. It doesn't have to be that way. It could be that you just need better equipment up front, and that might cost more money up front, but over time the costs reduce because you're getting your data faster, you're able to react on the results quicker. Further risks in the experience that I've had with designers is labs are often built way too big or way too small. Normally it's way too small. In fairness, they just try to get it right, because at the start there might only be 20 or 30 samples required. But what happens over time is as they get the commissioning right, they go, ooh, actually we need to do this, we need to do that sample, we need to do that sample. So often there's an expansion requirement from the lab, and it might be a financial restriction at the beginning. They may not have the finances required to build a big lab. So that's sort of understood, but you should allow for space and allow for expansion at a later phase, just in case it needs to happen. The other thing that some labs don't really appreciate is that if you're in a mine site that's close to a big city, like say near Kalgoorlie, you can do your own stuff on site that's important, but send off-site things that can take 2 or 3 days and send it to one of the commercial labs. So you can actually manage that way. You want to be careful with failed quality of work. You also want to be careful about the demotivation of good staff, and staff will leave if they get demotivated. You know, there's lots of lab jobs out there at the moment, and it's been that way for a few years. Won't always necessarily be that way. But right now, if I'm a labbie, I can probably apply for 5 jobs and I'll get 5 offers, because that's the way it is. If you need any further information, please contact us at Datamine. We can try and help you with the lab design and give you some advice. Hopefully you might take it on board. and if not, at least it'll give you some sort of an idea of where you're going. Thank you very much.